we're going to continue with the 5.2 notes today. So I'll just scroll down past where we got. We're going to start with margin of error. This describes the amount of variability. Now, we kind of talked about how the more samples we do, the less variable we get, and margin of error kind of tells us how much variability we have there. So, to find the margin of error, we are going to use this formula, which works for a 95% confidence level. I'll get to that in just a minute. And the formula is going to be 1 over the square root of n. Now, that is the estimated formula that we are going to use every time. So we're always going to use a 95% level, and our formula will always be 1 over the square root of n. There are other margin of error formulas that you might find out there. Find the margin. So the margin of error represents how much leeway we can get. So if we have a small margin of error, that means our data is really tight. Like, I'm only going to go up 1 or 2. But if I have a larger margin of error, that means I might go plus or minus 5 from my original data. Find the margin of error for the Gallup poll. So we're going to do 1 divided by the square root of n, and n is the sample size. So our sample size for the Gallup poll was 1,523. So the margin of error is 1 divided by the square root of 1,523. And you can change that to a decimal. 1 divided by the square root of 1,523. And you get 0.025, which is 2.5%. So the margin of error was 2.5%. Which means within going up 2.5 or down 2.5, in that range, we're accurate. The larger the sample size, the smaller the margin of error. I think if I change that number from 1,523 to like 100, that margin of error will get way bigger. So the larger the sample size, the smaller the margin of error. Okay, and then we have a confidence statement. It has 2 parts. It has the margin of error and the level of confidence. Okay, this always applies to the population. It's never completely certain. We're never going to say with 100% confidence 57% of the population buys lottery tickets, because we're not doing a census. It's usual to report the margin of error as a 95% confidence, and that's what we will use every time, because we're going to use that 1 over root n formula, which only works for 95. So, in the Gallup conclusion with the lottery tickets, here's the confidence statement. We are 95% confident that between 54% and 60% of adults bought a lottery ticket in the last 12 months. Now, where did those numbers come from? In the example we said, the statistic was 57% based on their sample. 57% of the population bought a lottery ticket. Well, our margin of error was 2.5%. So they round that up. They always round that up to the nearest whole number. So that way we went down 3%, 57 minus 3, and we went up 3%, 57 plus 3. So then we have this range. So anywhere between 54 and 60 should be accurate. If something falls outside of that range, there's only a 5% chance that the actual value will be outside of that range. That's what the 95% level means. So 95% chance that the real value is in there, 5% chance that the real value is outside of that. Okay. See, population size doesn't matter to gather good data. It's the size of the sample that makes a difference. Okay. We're going to open up a worksheet. We're going to go through a couple of those, and then you'll be working on that for the rest of the time. Okay, the worksheet looks like this. Numbers 1, 2, and 3 are very similar to what you did on the quizzes yesterday, so I think you'll do just fine there. Remember, they're not always numbers. Sometimes it's just a description of what you're trying to find. Let's do numbers 8 through 12 together. Okay, doctor noticed that some female patients were vitamin D deficient. She'd like to determine what proportion of her patients are deficient. So she chooses a random sample, 45 files, 37 of those 45 were vitamin D deficient. All right, so the margin of error for a 95% confidence interval. So that's where we do the 1 divided by the square root of n. So in this case, n is the number of files that she picked. So that's 1 divided by the square root of 45. So our confidence interval is 14.9%. And we'll round that up to the nearest whole. Sorry, our margin of error is 14.9%, so we'll put 15% there. So then the 95% confidence interval means we're going to take the statistic that we have, and we're going to add and subtract the confidence interval, or the margin of error. All right, so the statistic is 37 over 45. So that's 82%. So right now, 82% of her patients are deficient. But we have a margin of error of 15%. So we're going to go up 15, and we're going to go down 15. So our confidence interval will be 67 to 97. Down 15, up 15. 67 to 97. And then the confidence statement. I am 95% confident, always 95% confident, that between 67 and 97% of females are vitamin D deficient. All right, so you've got your confidence statement, and you've got your interval, and you've got what's going on. I'm 95% confident that between 67 and 97% of female patients are vitamin D deficient. For 11, the doctor is unhappy with this confidence interval. It's so wide. It is 30 points. But she does not feel like she has a good estimate. What can she do to narrow that interval? Well, confidence interval is determined by margin of error. Margin of error is determined by sample size. So if you want a smaller margin of error, you need a larger sample size. So she needs to increase her sample size. If she increases the number of patient files to 180, what will happen to the margin of error? So we're going to do 1 over the square root of n again. 1 divided by the square root of 180 is 7.5%. So I get 0.074 on my calculator, 7.5%. So that takes our margin of error and cuts it in half. Because we had a 15% margin of error, now we have a 7.5% margin of error. Okay, I want you to work on this for today. If you have any questions, ask them with me.